Okay, so now that we've talked about resting potentials, we're going to move into talking about graded potentials. So at rest means the nerve is not sensing anything, it has no signals. But let's talk about what happens when a stimulus starts to come in and the neuron starts to sense this. Okay, so what's going on there with the graded potential, and you can read all this text here about what causes it, but what's going on is that ions start to move, and that's going to change that -70 value into something different. And so what I'd like to do is to now switch to an active learning exercise that I hope will help explain this more. Okay, so here we've got our active learning exercise, but we have some of the different, and we still have the cell membrane drawn here. We still have the outside of the cell and the inside of the cell, as we did before. Okay. This time, though, we're going to have different players along the membrane. We're still going to have our sodium-potassium exchange pump. Okay, but this time let's add some different channels. Let's add the chemical gated sodium channel, and you may notice that here this channel is closed. I've printed it out so that it has two sides to it, but here notice it's closed, nothing can get through. So we're putting that down here. Let's also put down, this right here is the voltage-gated sodium channel. And it's actually going to have 3 different sides to it. Okay. You notice here both gates are open. You notice here that the bottom gate is closed, the top is open. We want to start off where the top gate is closed, the bottom gate is open. And I use a little paper clip to put it into place. And then the last one we're going to look at is the voltage-gated potassium channel here. You notice this also has 2 sides. Here it's open, and here it's closed. Okay? And so we're going to put that on the membrane too. Now, just like we did before, we're starting at rest, and so we're still going to have positive inside the cell, or positive outside the cell, and negative inside the cell. Okay. And we're still going to have high levels of sodium on the outside of the cell and high levels of potassium on the inside of the cell. Okay. So, this is the setup at rest. Now, let's just talk about the graded potential. So, for example, let's say my hand, I cut it. My body is going to release a chemical called substance P. Substance P is a neurotransmitter. Okay? And so, neurotransmitter is going to come and it is going to bind to my chemical gated sodium channel. That opens it. And when that happens, a little bit of sodium comes in to the inside of the cell. Now let's remind ourselves, we started at -70 millivolts. Okay? But now we've brought something positive inside. So we are going to get less negative. And in this case, we're going to switch to something closer to -60 millivolts. So we could be at -65, -64, but we're moving from -70 all the way up eventually to minus 60 if our stimulus is strong enough. So this is an example of a graded potential. We're moving from minus 70 up to a minus 60. Okay, so we're graded. And this channel that does it is the chemical gated sodium channel. And what causes it to happen is neurotransmitter binds to this channel and opens it. That allows sodium to come in. Okay, now what you also need to know about graded potentials, you'll notice that here they're drawn, graded potentials are drawn right here. And that's because this is where graded potentials occur. They're going to be occurring on the cell body or particularly in that axon hillock area. Now why do they occur there? Well, it turns out, remember, this is our channel that's the major player for the graded potential. Notice this red dot is neurotransmitter binding, which opens it. Here it's not bound, so it's closed. And so those chemical gated channels are located on the cell body and the axon hillock. And so that's why graded potentials occur in this area. Now, I just want to point out again, graded potentials, and this is a simple version. We're going to add some complexity towards the end of this lesson. But with the chemical gated sodium channel, here minus 70 is at rest. And when a stimulus occurs, this is what the graded potential looks like. We're getting a little bit closer to that minus 60. Now, let's say we have a weak stimulus. We may feel it, the mosquito may land. It's stimulating that part of our skin, but it's not sending a signal to our brain, and so eventually that signal goes away. Okay? So what we'll talk about next is what happens if that signal, that stimulus, is strong enough that we reach minus 60. What happens next? But this is just showing a graded potential, and it can, if it's weak, it's going to happen and then go right away. And we may not even know.